Hi everyone, this is Darren from PostgresCourse.com, and today what I want to share is what many people say is the most useful module provided in Postgres. This module is provided as an extension and it's called pgstatstatements. And so let's just get started taking a look at pgstatstatements. So what I'll show you is here on this machine, I don't yet have it installed. Instead, I'll need to install it. So for many extensions, including pgstatstatements, these extensions come along as a package called contrib with many installation approaches with Postgres. So if you have a contrib directory with the method that you use to install your Postgres, then you're already good to go. But in case you don't, this would be a sample command that you would use for, say, a Red Hat or CentOS based system, where I'll just say install the contrib modules. These are additional contributed modules that go on top of the core Postgres product. All right, so that's installed, and that will help me get access to a number of extensions, including pgstatstatements. Once I actually have it installed, I'm going to switch over to my Postgres system user, and I want to enable that extension. This particular extension requires that I modify the PostgreSQL.conf file and add pgstatstatements to the shared preload library setting. So I'll take that step by step and explain what it means. The first thing that you'll need to do is know where your PostgreSQL.conf file lives. A couple ways you could do that is you could echo the pgdata environment variable. This is not a method that always works. This requires that your installation method did set an environment variable called pgdata, and I can locate where that's set up. So that's the data directory for my currently running cluster. Another way I could find out where my PostgreSQL.conf file is located is simply by logging into my cluster, and then I could type the command show data underscore directory, and there I get the same output. In any case, once I've located it, I can edit my PostgreSQL.conf file. So I'll edit that. I'll use the environment variable to shortcut the path. And what I'm looking for is this setting here, shared preload libraries. And I'll just change the terminal background really quickly to make that easier to see. There's a setting, shared preload libraries. So I will uncomment that line. I'll enter into that pgstat statements. This shared preload library setting essentially allows the pgstat statements extension access to additional shared memory. So because that's what that extension needs, then I'm able to add the module this way and provide access to additional shared memory. Notice here, this change will require a restart. I'm going to change my screen back. So after I make that change, then I'll restart my cluster. Cluster's restarted. So what's the next step? Well, I want to specifically install this extension on a database named Oregon. Now, that's one other thing you should know about pgstat statements is it needs to be installed and enabled on a database by database method. So the same change I just made to add pgstat statements to shared preload libraries in the configuration, that is cluster wide. But to enable this particular extension for a particular database, I need to go database by database and enter another command. And that command is pretty simply create extension pgstat statements. It echoes out create extension. And now if I take a look at the relations that are available, this is one thing that we should know about pgstat statements is it adds a view to each database where it's enabled that allows us access to a particular number of statistics on SQL statements that have been executed on that database. So here in Oregon, we have this new view called pgstat statements. What does it provide? Well, Take a look at pgstatstatements. The best approach would just be go straight to the documentation. So I've already got that pulled up. And here there's a number of statistics gathered by the module that are listed here in the documentation. Everything from total time for a particular statement over every single time it's executed to the number of times that it's been called, uh, minimum time it takes, maximum time, mean time. These are all in milliseconds, by the way. Storage blocks that are hit, whether memory or read from disk, and so on. So it's very useful. How would I actually use this in production? Well, right now I'm gonna change my table view to be extended to make it easier to see. And I'll say select R from PG stat statements. All right, and right now there are a number of statements that have been executed, and they're all really hitting system catalogs. None of these are things that I've directly called. Most of them have been called about 3 times or so. So let's actually artificially bolster that up so we can kind of see what it will look like in a test environment. So what I'll do is I'll just write a quick little bash script here on the command line. So I'll do select star from employees. And that little script will execute that command 10 times, or 100 times rather. So there's one execution, and then I'm going to edit the video so you don't have to see the other 100 times I executed. Okay, so that executed about 100 times. Let's do that again, but I'm going to make it a little bit smarter this time. I'm going to have another script that runs 200 times. We're going to look for the count employees, and this time, so that I don't have to edit the video, I'm going to smartly send the output to temp file. So that's what that looks like. So it'll execute that count 200 times. Type it correctly, it will. So there we go. So now let's go back. Keep in mind, this is what the pgstatstatements view will provide. Let's take a look at the calls. Let's take a look at all statements executed in the organ database, but let's order them by the number of times they've been called. You can see how that could be valuable in a production environment if you want to know, hey, what queries are my particular applications running the most? What queries or calls are my users executing the most? And then we could take a look at, how long they're taking. So we'll do that real quick. So I'll log back in and we'll say select, change it to extended view, select star from PG at statements, order by calls descending. And notice, just like I said previously when I was testing this demonstration out, I called these select commands a little bit more. So you can see now they're rising to the top. I've called them 300 times. That's the particular query that was executed. How long did it take? Well, at minimum, it took 0.4 milliseconds. At maximum, it took 0.67 milliseconds. So your average is 0.59. How many rows were retrieved? Well, it's just retrieving a single metadata row. So only one row per execution. Let's take a look at the select star from employees. That one was executed 300 times. Takes about 6 milliseconds at the least, 7 milliseconds at the max. So your average is 6.5. And then over so many times retrieving all 5,000 rows or so, then in total it's returned 1.5 million rows. So you can see how this definitely could be valuable in a production environment. That's just a quick demo and introduction to PG stat statements. Hope you enjoyed it. Remember to like and subscribe. Thanks for watching.